sign language.
I'm Juvy, Cariño, and I teach Advanced Robotics at Untalan Middle School.
Hi, I'm Rozalyn, Pama, and I teach Intermediate Robotics.
We have been piloting Intermediate and Advanced Robotics since 2019, but due to the pandemic, we were not able to fully implement it until school year 2021-2022.
This is our pilot evaluation of Intermediate and Advanced Robotics.
Objectives.
Objective 1. Given robotic kits and use of technology tools, students will learn and apply how to effectively collaborate in groups. Due to public health restrictions, students were limited in movement and contact. For intermediate robotics students, I was able to pair up students randomly for each mission, but given specific duties. One student is assigned the technician and the other the programmer. The technician handled the robot and placed it on the course while the programmer worked on the laptop. For every new mission, a new partner was assigned randomly. This helped students to learn how to communicate with each other. Although they worked in pairs, they each had to work on their presentations and reflections independently.
While collaboration was a challenge during the beginning of the year when schools went back completely online, and later when we had A and B cohorts scheduled, the students used online tools to collaborate ideas and provide feedback on each other's projects. Activities included discussing the importance of digital citizenship in the class Zoom chat, collaborating to build a robot across different class periods, programming a soccer game between two players, and programming an app using JavaScript language and providing feedback on each other's app on Padlet.
Objective 2. Given robotic kits and the use of technology tools, students will learn and apply how to effectively use the design process to solve problems. For intermediate robotics, students are expected to complete their mission, but in the process learn to improve their program by testing it out and making adjustments.
For advanced robotics, according to their self-assessment and reflection data, many students expressed that they improved their problem-solving skills. Objective 3. Given robotic kits and use of technology tools, students will learn and apply how to use gear systems, pulleys, sensors, and attachments for specific applications.
For intermediate robotics, students learned how to attach and program the color and ultrasonic sensors. Both sensors were used to navigate through a course.
For advanced robotics, we concentrated on the application of sensors and attachments through the completion of missions. They used the touch sensor with bumper car attachment, the ultrasonic sensor to move the robot or make sounds, and the color sensor to follow a line and make sounds. Objective 4. Given robotic kits and use of technology tools, students will learn and apply how to build, program, and test robots to solve obstacle courses.
At the intermediate level, students learned the basics for programming the EV3 robot. We went over simple movement blocks such as moving straight and tank blocks to program robots to move forward, backward, and perform basic turns. We also introduced a couple of sensors such as the color and ultrasonic sensors to navigate the robot through simple obstacle courses.
At the advanced level, students reinforced their rigor as they built, tested through trial and error, and completed the task of pushing a basket through a Lego neighborhood using precise speed, careful navigation, and specific turning techniques. Objective 5. Given robotic kits and use of technology tools, students will learn to become a digital age learner according to the GDOE technology standards.
For the first semester, students were evaluated according to the standards of Empowered Learner, Digital Citizen, Creative Communicator, and Knowledge Constructor. They are currently focusing on Computational Thinker and Innovative Designer for the second semester. Curriculum. Intermediate Robotics is a middle school elective course which introduces students to developing, building, and programming a robot through the use of the problem-solving process. Students work cooperatively to find solutions for real-world problems such as disaster operations, underwater research, and space explorations.
Advanced Robotics is a middle school elective course which continues the course of study of intermediate robotics. Students continue to develop, build, and program a robot through the use of problem-solving process. Technology and engineering topics include robot construction, robot programming, using sensors, using passive and active attachments, and solving obstacle courses. Instruction. The instructional strategies used include the research-based classroom instructions that work, CITW, especially identifying similarities and differences, summarizing and note-taking, non-linguistic representations, and generating and testing hypotheses. Additionally, the Big 8 will be used to get students engaged, especially expectations, cueing, and tasking.
Assessment. Methods used to assess student learning were individual student progress or proficiency levels on the priority standards that the instructor set at the beginning of the school year. Students were also evaluated through a skill acquisition self-assessment and a student reflection of the program lessons. Here is the intermediate robotics data. Our robotics data can be found on our school's robotics website, sites.google.com/gdui.net/LPUMS-robotics. Here, you will find an overview of our robotics program as well as links to our web pages for intermediate and advanced robotics.
Scroll down our website and you will find this section. We will go over them in the next few minutes in this presentation, but you may review them at any time by going to our website.
Our robotics students are expected to be proficient in all of our technology standards by the end of the course. For intermediate robotics, that would mean scoring a level 3 and above. During the first semester, the 3 standards that were taught were Empowered Learner, Digital Citizen, and Knowledge Constructor. For Empowered Learner, the mode of assessment was through assignments. Class 1, 71.4% met the target or better. Class 2, 55.0% met the target or better. Class 3, 55.6% met the target or better. Class 4, which is my pre-AP 6th graders, 91.3% met the target or better. Class 5, my pre-AP 8th graders, 93.3% met the target or better. Digital Citizen. The mode of assessment is through assignments and projects. Class 1, 100% met the target. Class 2, 80%. Class 3, 100%. Class 4, pre-AP 6th graders, 100%. And Class 5, pre-AP 8th graders, 100%. And for Knowledge Constructor, the mode of assessment is through projects. Class 1, 78.6% met the target or better. Class 2, 50%, Class 3, 33.3%, Class 4, 100%, and Class 5, 86.7%. As you can see, the standard Digital Citizen was the standard that most students were able to be proficient at. Now, for second semester, we have Innovative Designer, and the mode of assessment is through projects. Computational Thinker, mode of assessment is through quizzes and projects. And the last standard for intermediate robotics is Creative Communicator. The mode of assessment is through presentations and projects. Because we are halfway through the semester, I don't have any final scores for these 3 standards, but I can tell you at the start of second semester, students for these 3 standards were at a level 1, they were beginning, and as they went through each mission and learned how to do the programming and to code, most of them are at level 3 or better.
And here's the advanced robotics data.
For advanced robotics, this is how the 7th and 8th graders compared in terms of meeting level 3 proficiency, which means that they demonstrated understanding and mastery of the standards, content knowledge, and skills. For first semester, my students were evaluated on 4 standards, with the mode of assessments ranging from quizzes, assignments, and hands-on projects. Overall, more than 60% of my students were at level 3 or above for all four standards. Similarly, as intermediate robotics, standard 2 digital citizen was the standard that had the highest amount of achieved proficiency, while creative communicator had the lowest. Besides the standards, we did two other student assessments, and you can see them on the website right here. If you click either one of these links, it will take you to the results of our online surveys that was done on Google Forms, on student self-assessment survey, and the student reflection on the lessons. We will now go over the results of these surveys.
Student self-assessment survey for intermediate robotics.
Computer and online safety. I can competently and safely use a computer without asking for help, with 0 being I cannot do this at all, 1 I can try, 2 I can do some but I'm not confident, 3 I can do this, 4 I can do this very well. At the start, 38.9% of my students felt that they were a level 4, and at the end, 61.6 students felt that they were a level 4. I can competently and safely go online using the internet in order to check my email and do my assignments on Google Classroom. At the beginning of the year, 52.8% felt that they were a level 4, and towards the end, 76.4% felt that they were level 4. I can troubleshoot my student laptop if a problem arises. When the problem is too big, then I ask my classmates or the teacher. At the start of the school year, 31.9% felt that they can do this very well, and towards the end, 47.2% felt that they can do this very well. I can take pictures and video using my student laptop. At the start of the school year, 30.6% of my students felt that they can do this very well, and it rose to 45.8% towards the end of the school year. I can edit videos that I have taken of my work using an editing software such as Flipgrid, iMovie, CapCut, Video Leap, etc. on a laptop, iPad, or phone. At the start of the school year, 33.3% of my students felt that they can do this very well, and it rose to 43.1% of my students that felt that they can do this very well. I can build structures, robots, and rovers using the LEGO Mindstorm EV3 kit. At the start of this school year, 16.9% felt that they can do this, and 22.5% felt that they can do this very well. And it rose towards the end of the school year with 50.7% that felt that they can do this, and 32.4% of my students who felt that they can do this very well.
What other skills do you think you learned in robotics class? Some things I do want to highlight: how to work with other people with different personalities, teamwork, problem solving, how to operate robots, communication skills, patience and determination.
Skill acquisition self-assessment for advanced robotics. I can recall the names of at least 8 parts in the LEGO EV3 Mindstorm kit. Only 3% at the beginning of the school year, 43.5% at the end of the school year. I can do visual programming using the EV3 Mindstorm software. 4.8% at the beginning, 33.9% can do this very well at the end, and 45.2% can do this. I can solve programming problems with the EV3 robot in order to complete missions on the obstacle course. Only 3.2% said they can do this well at the beginning of the school year. At the end of the school year, 29% said they can do it very well. I can troubleshoot my EV3 robot if a problem arises. I ask for help from my classmates and my teacher if the problem is too big. 8.1% said they can do this very well at the beginning, and that rose to 29% at the end. I can edit videos that I have taken of my work using an editing software on a laptop, iPad, or phone. At the beginning, 32.3% said they can do this very well, while at the end, 50% of the students say they can do this very well. I can code an app that is interactive with text, pictures, buttons, and sound. Only 4.8% said they could do this very well at the beginning, while at the end, 40.3% said they can do this very well. What other skills do you think you learned in robotics class? So these are some of the comments, all very interesting, very similar to intermediate robotics students and what they put down in their comments. Problem solving skills, being patient, following instruction, how to work well with others, speaking out if I need help, learning how to problem solve. All very important skills to learn.
And here's a reflection from students on the intermediate robotics lessons. Think about the previous lessons that you have had in intermediate robotics. What lessons do you think would help you in high school? Most of them chose digital citizenship at 74%, followed by creating presentations and editing videos, as well as building and programming the Mindstorm EV3 robots. Which lessons did they find the most challenging to learn? One that they found the most challenging to learn was programming to complete an obstacle course with 68.8%, followed by programming turns at 45.5% and programming motors and sensors at 44.2%. Which lessons did you find the easiest to learn? Digital citizenship at 71.4%. If you recall in our proficiency levels, digital citizenship was the standard that most students were able to be proficient at, followed by the introduction of robotics and its history, and the introduction of Lego and its history. So the engagement and interest in intermediate robotics lessons, the lessons that they found the most interesting was programming to complete an obstacle course. Now, if you look back, that was the most difficult, but it was the most engaging for them, as well as building and programming Mindstorm attachments and the other programming activities that we have in this class. From the list of lessons you thought were challenging, what made it challenging? What made some of the lessons challenging was that I would get confused with the different programs. Trying to complete a program mission was the hardest because I had to control the robot with different codes. Also, programming sensors and motors were difficult for me because I had to match the movement codes with the right one, and it was confusing. Editing videos was also difficult because I've never edited videos before, and also editing pictures. Another one, the programming part, because you have to get every angle right, every turn right. Sometimes it wasn't always perfect, but our teacher the teachers kept us encouraged, and we would get it done by the end of class. If it wasn't done by the end of class, they would give us the next class to try and finish it. For me, it is the programming part, which was the hardest, since we are all paired with all walks of life. So that meant I get paired with some people that do not really know how much about it, which I like to help them out. It is just kind of challenging. Although I love to help people, it is very stressful for very new people.
Student reflection results for advanced robotics. Lessons that prepare students for high school. Majority of them said editing videos. Then next is creating presentations. And then digital citizenship, that these would help them in high school. Lessons that were most challenging. Programming to complete an obstacle course was challenging, and so was creating an app using JavaScript. And distant third, programming motors and sensors. Lessons that were easiest for them, digital citizenship, 76.2%, followed by intro lessons. Engagement, interest in the lessons. The ones that had the most interest and engagement was creating an app using JavaScript, along with creating presentations, editing videos. The others had not as high engagement. What made the lessons challenging? Learning how to program for the first time is what made it challenging. Before I took this class, I was clueless about programming and what it was about. When I started to learn about how to program or code, I found it difficult. Programming for the first time and solving challenges to complete tasks was an obstacle. But even though there were many challenges I had to face, I learned many new things like problem solving and having creativity. These challenges helped me to learn and grow my knowledge. Many of them had similar sentiments. What made these lessons challenging was not really knowing how to program or how to build them. I'm not going to lie, robotics is a pretty challenging subject, But it's something I'm glad to have this subject and to have the opportunity to learn these new things. But even though they were challenging, I still had motivation to get it done. What made the lessons easy to learn? It was easy because I enjoyed it. The way it was explained in the video made things even easier for me, and I could just look back on what I did to see what I did wrong. It was easy to learn because I had at least instructions to help me, or the teacher was there to help me. Sometimes it was because I could understand how to do it and I was interested in it. That would be because I had actually had fun with it, I was interested in it, and the programming was easy. The things that are most interesting are always the ones that are easiest.
Structure. Intermediate robotics and advanced robotics were scheduled as elective classes in the school matrix. At the end of the previous year, the counseling office gave 6th and 7th grade students an elective preference form to complete. Some students were scheduled from that form.
Students in the pre-advanced placement team were also scheduled in the robotics classes with 6th and 7th grade students in intermediate and 7th and 8th grade students in advanced. LPUMS has block scheduling with 80-minute classes. Schools who will implement robotics as a class must consider the additional time needed to set up and clean up equipment and kits.
Challenges. One of the challenges we encountered were hardware, software, and firmware issues. Downloading updated Lego software into the student laptops and class iPads was challenging because of network restrictions and incompatibility with older robotics kits.
Another challenge was scheduling students into the pilot classes. The complex school matrix of core and elective classes has been challenging for the administration. LPUMS has pre-AP students with set grouping in one team and an additional pre-AP class per grade level. This complicates the periods in which these students can attend either intermediate or advanced robotics. Besides our robotics program, LPUMS has other stratified elective classes that require prerequisites.
And of course, COVID-19 and Guam public health restrictions limited the proper implementation of our objectives. Due to the number of robotics kits available and the difficulty of sharing supplies, the number of students enrolled into the pilot classes was limited. Collaboration was a challenge due to distance requirements. Sanitizing of robotic kits, laptops, and iPads also added to the setup and cleanup times.
Successes. Students learn a variety of skills besides technology that will help them in high school and in the workforce, such as improving their problem-solving skills, patience, rigor for trial and error, and working collaboratively with others.
Based on our self-assessment survey, an overwhelming number of students shared that they were engaged and interested in both the intermediate and advanced robotics lessons. Many of them shared that the lessons challenged them and tested their perseverance.
Lastly, we are proud to share that teaching both robotics classes allowed us to use a variety of teaching strategies and tools in our arsenal. For example, we use many online platforms such as Code.org,
MIT Scratch Programming,
BrainPop,
Flipgrid,
YouTube,
Padlet,
Quizlet,
Quizzes,
Kahoot,
Bluekit,
Pearduck,
Nearpod,
and all the Google Suites apps.
And don't forget to go to our robotics website at sites.google.com/gdoe.net/LPUMS-robotics. There you will find our student work samples.
And that concludes the evaluation presentation of the Intermediate and Advanced Robotics pilot courses at Louis P. Untalan Middle School.
We would like to thank the support of our administrators, Agnes Guerrero, Gayleen Cruz, Corazon Ilani, our administrative officer, Jeanette Suprales, and former AP, Beth Paris.
Additionally, thank you to the GDOE Curriculum and Instruction Division for your guidance.
Thank you!
Have a great day!